This meeting is being recorded.
Section 2 from Chapter 10 introduces us to the patterns that we're going to hopefully recognize in radical mechanisms. And these are, we're going to compare them to ionic mechanisms, which we've seen in the past, such as when we have carbocation formation. So these radical mechanisms, they also follow patterns, just like the ionic mechanisms did, but they're very different. And for example, down here, we have our first example of the differences, a carbocation shown on the left here. This can rearrange to form a more stable tertiary carbocation. And in fact, if it can rearrange, it will rearrange. But a radical will not do this. So this would remain a secondary radical, whereas this could become a tertiary carbocation. So the reaction site will remain at the secondary site if it's a radical mechanism, whereas we would see a difference in our product in an ionic mechanism. We would see a tertiary product, for example, in certain reaction mechanisms. So let's look at these patterns in detail. Our first pattern is that of homolytic cleavage. So this can be initiated by either heat. So we see this triangle, this delta on top of our arrow that indicates heat can be initiation for this step, for this homolytic cleavage, or on the bottom, that arrow that I just drew there, that indicates light, that H nu. That is the indicator of light being the breaking this homolytic bond here, or breaking this bond homolytically rather. So once this bond has enough energy to be broken, we see one electron move to the left, one electron move to the right, and we generate our radical here. So in general, an X can be used to represent halogens. So this could be Cl2, we could see bromine, iodine, any of these could be our X for these types of reactions. The second pattern that we'll take a look at is addition to a pi bond. So this is where we have a radical species here, our X radical. What happens is the pi bond here, one of the electrons there moves out to form a bond over here. The electron from our radical joins up, and we see this bond form over here. At the same time, the other electron in the pi bond moves over here to form this new radical site. So in pattern 3, we have hydrogen abstraction. So we're going to remove a hydrogen from this HR species here, and we're going to generate a new radical. So our radical X approaches, and its electron gets involved in a bond, and so does one of the covalent bonds between, one of the electrons in the covalent bond between H and R. So we will have this new covalent bond formed between X and H, and then we have a new radical produced. So that's what our R with the dot indicates. So this is not the same as a proton transfer, though. So that's good to note, because with a proton transfer, we're moving both of the electrons. We're not going to be just moving one and generating a new radical. So we have pattern number 4, kind of similar to hydrogen abstraction. We have a radical of some sort coming in, but now we're going to be removing a halogen, so that X will be removed. We see those two electrons move, so the radical electron, the electron from the covalent XX bond, we get this new molecule species over here, the Rx, and we create a new halogen radical. So these are the first 4 patterns that we should learn to recognize. Then we have the last 2 here. Now we have an elimination pattern. So this is the reverse of the addition that we saw previously. So we can have our X species generated here through movement of that radical electron. So one of the electrons in this single bond here to the X moves in, and the other electron from the radical site moves in, and we form a pi bond here. So that's what's shown over here. And in our last pattern, the coupling pattern, we have two radical species that each contributes an electron to this covalent bond here. And this is the opposite, you can think, of homolytic bond cleavage when we have this coupling of two radical species. So let's see on the next slide here, they organize each of these patterns in pairs. So we have homolytic cleavage being the opposite of coupling in this first box here. Then we have our second box over here where we have the opposite reactions of addition to a pi bond and then elimination. So you can see we're going back and forth between reactants and products. And then down the bottom, this last box will star. That shows how hydrogen abstraction and halogen abstraction can be considered opposites as well. So when studying these patterns, it might be helpful to group them in pairs of opposite reactions. So furthermore, these patterns that we just learned to recognize, now we're going to group these into different steps within a radical mechanism. So our first step is going to be an initiation step. Then we're going to see the second generalized steps would be propagation. And then we have at the end, we have some termination step. So our first step here, our initiation step, this is where we create a radical species from a non-radical. So up top here is our non-radical. We see homolytic bond cleavage and formation of our radicals here. Next, we have some propagation patterns listed down here. So any of these patterns, so addition to a pi bond, hydrogen abstraction, halogen abstraction, and elimination, so all four of these types of patterns could be considered propagation steps. And depending on the reaction, we may see them in different orders. So we have a radical now in all of these steps reacting with a non-radical species to form a new radical. And then in this case, a new radical and non-radical species. Or I'm sorry, in this first case, only a new radical species, but in each of these cases, we're going to have these three. We're going to have a radical and non-radical. So looking at our last patterns, these termination steps that can occur, these terminate, so they end the reaction from continuing. So coupling is where two radical species join together to form a non-radical. And we'll get a little more into detail and specifics from reaction to reaction of each of these phases in our radical reaction mechanisms. So we'll continue with section 10.3 next time.